Let's quickly go through this arithmetic progression. First, what we're going to do is we want to put the formulas that we're going to use, and then we're going to go through a bunch of questions and see and just get the concept of how we actually do solve. So these questions are going to be broken down into two. The first one is simple ones, which actually tell you have an arithmetic progression, and then at the end we'll do ones which don't tell you, okay? Ones which give you a scenario, and we'll see how we can always find out it's an arithmetic or whatever. So what is an arithmetic progression? Remember, the other word for progression, we can put a soft cancel. The other word for progression is sequence, okay? We'll be dealing with an arithmetic sequence. What it would be is you're going to have a bunch of numbers, and these numbers would be like 1, 2, 3, 4, 5, keeps going on. We put like 3 dots. Or we could say here we have, let's say 2, 4, 6, 8, 10, it keeps going on, right? Now, what will be happening is, or we can even say 1, 3, 5, 7, 9 keeps going on. Or we can have one which goes down, could start at 10, then 6, then 2, then -2, and it keeps going like that. So we can put dots, dot, like this. So what happens here is, an arithmetic progression is, remember, the word progression or sequence is we have numbers that are separated by a comma. So we have numbers that are going to be separated by a comma. The time when we have them add, we'll be now calling that a series. So series are the ones where numbers are separated, consecutive terms are separated by a plus. But in here, they'll be separated by a comma. We'll be calling it an arithmetic sequence or an arithmetic progression. Now, when it's called an arithmetic progression, it is when the consecutive terms have the same number separating them. So here are the two situations. Look, let's work with this, and then I'll show you some. Here you have from 1 to 2, you have 1. From 2 to 3, you have 1. From 3 to 4, you have 1. From 4 to 5, you have 1. Here from 2 to 4, you have 2. 4 to 6, you have 2. 6 to 8, you have 2. 8 to 10, you have 2. And how you always find out is you say the term ahead minus the term behind, and you see what difference. So it's, if we say 10 minus 8, we get 2. If we say 8 minus 6, we get 2. If we say 6 minus 4, we do get 2. If we say 4 minus 2, we get 2. So it's the term ahead minus the one behind. You will see what we're calling common difference. If you see the terms having the same number separating them, it's an arithmetic progression, because they have what we call a common difference, which is the same value separating consecutive terms all the way to the end. Here we can go to the one below. 9 minus 7, 2. 7 minus 5, 2. 5 minus 3, 2. 3 minus 1, 2. This is another arithmetic progression. Here we can say minus 2, minus 2. You can try that in the calculator, okay? You'd say what is minus 2, then minus 2. You'd get it as -4. So here there's a -4. Then 2 minus 6, you get -4 again. 6 minus 10, you get negative. So this one is going down by 4, and that's another arithmetic progression because the numbers are reducing by the same value. So an arithmetic progression, it is when you have, we call it a common difference, and we'll be using the symbol D. Okay, our values are separated by the same. There is an easy type of arithmetic progression which you're going to see, and that is the multiplication table of any number So let's say we have the multiplication table of 5. Okay, 5, 10, 15. Okay, 5, 10, 15, 20, 25, 30, keeps going on, right? Dot. When we have a situation like this, the moment you see a multiplication table of anything, even for 3, even for 7, to say 7, 14, 21, 28, 35, 42, 49, this 42, then 49, it keeps going on. This is definitely an arithmetic progression, because if it's the multiplication table of 7, it means the values are all separated by 7. And that makes it an arithmetic progression. 14 minus 7, 7. 21 minus 7, 7. 28 minus 21, 7. So here it's an arithmetic. 10 minus 5 is 5. 15 minus 10 is 5. 20 minus 15 is 5. 25. So here we have another arithmetic. So anytime you have a multiplication table of something, you'll be having an arithmetic progression. So our job, we are going to have two types of series, of sequences or progressions. Remember, progression is also called a sequence, separated by a comma. We're going to have an arithmetic one and a geometric one. An arithmetic one is when the values are separated by the same value. In geometric, they won't be separated by the same value. So here they're separated by the same value, and we said we call it our common difference. So we're going to have formulas. And these formulas help us to be able to know when we have an arithmetic progression, we can say, what is the term number 50 of this progression? What is the term number 200 of? Instead of you listing all the 200, you can easily calculate it without listing them. And there's a formula for that. And we can also say, what is the sum of the first 20 terms? What is the sum of the first 49 terms? You can easily get. So we can either get a term on our sequence, or we can get the sum of that. And for an arithmetic progression, it has a formula. For geometric, it has a different formula to finding these two things, which is one, the term, the missing term, we'll call it the nth term, and then the other thing is the sum. So we need to know, how do I find the nth term and how do I find the sum? So here you should know that on your arithmetic progression, there are two things you must always identify. Number one is your first term, and we'll call it A. A is going to be the first term. If they give you the numbers listed already, then you just have to look for the first term which is listed, and it's going to be your A. It is the first term of your sequence, right? And then D is going to be the common difference, which is, you say term 3 minus term 2, or term 5 minus term 4, or term 7 minus term 6. It is the one ahead minus the one behind. You get D. So this is going to be D, our common difference. D is going to be the common difference. You are going to look for that. If the common difference is the same for guys in that sequence, then you know it's an arithmetic progression. And once you identify, oh, this is an arithmetic progression, then this is how we then find the things. We say Tn, this is going to be the nth term, okay? It is going to be A, which is the first term, plus you say n minus 1, then times D. And n is going to be the number of terms. So you can say n is number of term, okay, of terms, or we can say n is the term number. We can either say the term number, okay. If it's for sum, we'll be calling it the number of terms. So if we're saying Tn, if we say T6, it means we want the sixth term, because n is telling you the number of that term. So that means our n will be 6. This is going to be the formula. A plus n minus 1 D. There is a way to derive it, but I'm not going to waste time doing it because we don't have that. Now, the other one is going to be for the sum. For an arithmetic progression, how do you get the sum? The sum is going to be n over 2 outside. Then inside we say 2a plus we say again n minus 1 of D. So there is an n over 2 outside, and then instead of an a in here, it will become a 2a. But this n minus 1d does not change. And tell you what, in real situation, n minus 1d, n minus 1 just means one term behind the one you are getting for. So you don't actually have to struggle to find n minus 1. Let's say you want the sixth term, you want the sum of 6 terms. What will you be putting here? 5D, because this is the sixth term. Okay, so it is 6 terms, so in here we put in. So if I want term number 7, so T7, in here I'll put 6D, okay? So the D's are one less than the term number, okay? Or the number of terms. That's going to be so easy. And you just need to know your A and your D. And this is what we are going to be using. And from there, we can get anything that we need. Sometimes there's an easier formula, which we hardly use, but you can have it. You don't really need it. It is when you want to find again the sum, and you'll be using the first and the last term. So it will be the sum, we can say, is going to n, then multiplying A plus L over 2. This means the average. First term plus last term divided by 2. You can have it like that, okay? The average of the first term and the last term. L is the last term. So you say last term. And then you can also use this to get the sum. But we will hardly use it. I don't even know one situation where I've used it before. You can use it, but you don't have to. Okay, you can hardly. But if you know the last term and the first term, you can use this to then find your sum. All right, so these are going to be the formulas. These are the only things you actually do need to know. Number one is to then identify that this is an arithmetic progression. Then you now need to know these two formulas by heart, and then you can be able to apply it. Remember, you won't be given these formulas. You have to know them by heart. All right? Goodbye. See you in the next one.